Okay, so on this one, you're going to be graphing functions. So you're going to be given a function, and you're going to need to be able to put some values into a table and graph it. So here's our function for this case. And so what we're going to do is with these parabolic functions or with parabolas, if you don't see like the parentheses like you would in the graphing form, that usually means it's somewhere down here in the middle of the graph. Okay, so unless you see it like this, that means it's somewhere in the middle. So what I'm going to do for the x values, because you might be wondering, well, how do I choose my x values? Okay, well, I know that's going to be right in the middle, and the reason I know that is because when I look at the function, it's almost like if there is no parentheses here. That means that the x value for the vertex is 0, and then that's like the outside value to the k value, which is 3. So I'm actually going to put that right in the middle of the table so that I can get points that, go around it. So to the right or of 0, or points going this way, I would have 1 and 2. And to the points above that would be the negative points to the left. So I'll go -1 and -2. Okay. So again, the same approach over here. If my vertex here is -2 and -3, which we got from graphing form, I would put that right here in the middle. And now what I want to do is figure out 2 points to the right. Well, if I'm at -2, 1 point to the right would be -1 and 0. And then to the left would be -3 and 4. Okay, so that's how you know what x values to put in, is you got to look at kind of where the vertex is at. Okay, so what I'm going to do is I'm going to plug in each of these values into the equation to figure out the y values. So here I would plug in 2 times -2 squared plus 3. And what you can do is you can plug this into Desmos or do it somewhere here on your paper and figure out what that is. But we'll just kind of quickly do it. It's -2 squared. Just do exponents first. That would be 4. Times 2 is 8. Plus 3 is 11. And the same thing here. Just plug in -1. Okay, so -1 squared is 1. Times 2 is 2. Plus 3 is 5. Okay, so here, 2 times 1 squared plus 3. 1 squared is 1. Times 2 is 2. Plus 3, that's also 5. Notice how we just got 5 again, right? So what that's going to mean is that this point will end up being 11. Because when I plug in 2, it'll basically be 2 squared, 4 times 2 is 8, plus 3, 11. Okay, so now let's plot those. 0 and 3, 1 and 5, -1 and 5. And then I can't really fit these problems on there because they'd be like way up here. So we'll just use those 3 points to complete our graph. Okay. And remember, just go ahead and do that with this problem there. Okay, so now, again, let's finish this. So now I'm going to plug in -1 to that function there. So -1 plus 2 squared minus 3. Okay, and then here, this would be negative. And then we plug in 0. So I'm just kind of setting them up. Okay, so here, this would be -1 plus 2. That's 1. 1 squared is 1. But then I got to multiply this negative. And then -1 minus 3 is -4. Okay, then the next one is 0 plus 2. That's 2 squared. Sorry, that's a little 2. I know it's hard to see. 2 squared is 4 times the negative would be -4. Then minus 3 is -7. Now remember when I told you here, like we got the same values here and up there. We got the same thing here. Okay, so if I got -4 and -7, that means this will also be -4 and -7. Okay, so let's go ahead and plot that. So -2 minus 3, -3 minus 4. There's those 2 points, and then -4, -7, and 0 and -7, the y-intercept. I notice this one's pointing down, right? Well, what's the giveaway for why it's pointing down? Well, it's because that we have a negative in front of the function, so that makes it kind of reflect down the other way. Okay, so now if we're looking at these problems here, we kind of zoom out just a little bit so we can see them all. Okay. So now let's not worry about these two here. It says write possible equations for each of these graphs and assume all axes are scaled by 1 unit. So these all go by ones. And check your equations on a graphing calculator, or basically use Desmos to check your answers. Okay, so let's first kind of identify these graphs first. Well, first, this is a parabola, right? So we are going to expect an x squared type of problem, okay, or quadratic. This type of form of graph, where it kind of comes up, levels out, and then goes back up again, that's a cubic. So this one will be an x cubed type of function. A straight line, well, if you remember, that's mx plus b, like we did in the first week. Okay, so here's another cubic.
It's so big they call it the.
Okay, if we look down, the ones down here. Okay, there's another cubic. Again, we're just identifying the graph so we kind of know what equation to use. Here's a u, a parabola that's upside down. So that's another quadratic, and so is this one. This is also another parabola. Okay, so let's use that idea to figure out what these graphs are. Okay, so here, the one thing I know is that vertex, right? Now vertex is at 1, 2, 3, 4, 5. Is at 0, 5. So I'm going to use graphing form and say x squared minus, oh wait, that x value of the vertex is 0, right? So it's just x minus 0 plus 5. Well, x minus 0 is just x, right? So I don't really even need to write x minus 0. I'm just going to write x squared plus 5. And then what I want to do is actually check that. Let's go on Desmos real quick and take a look at what x squared plus 5 looks like. I'm like, wait a minute, huh? Why is it above the graph? Because if you notice over here, it's below. Oh, so I made a mistake. That means I should have put negative. So I can just fix my mistake and go, oh, it should have been minus 5, not plus 5, right? So let's go back and check. Let's put that as negative 5. Oh, that makes more sense now, right? Okay. Okay, so now we're going to use that same approach to figure out all of these. Okay, so let's start with a cubic graph, right? A cubic graph, we can use the same idea that we did here with graphing form by finding kind of the locator point, which is basically the middle of the graph. So that middle of the graph is at 3, 0. And instead of squared here, now we're going to use cubed. Okay, and so it's x minus 3 and then plus 0. So that's it. So let's see what that looks like. Let's just double check it. So x minus 3. And then we're going to put a little cube up here. And that looks pretty much the same graph, right? Okay, so we can keep double checking as we go. Okay, so now here we got a straight line, so that means we need to figure out the slope and the y-intercept. Well, there's your y-intercept, and then you guys are going to need to figure out the slope. I'll give you a hint by taking 2 points and figuring out the rise, how far up, over the run. So the rise is 3, the run is 1. Figure out what that y-intercept is, plug that into your b, figure out your rise over your run, and plug that into m, and then you should be able to figure out your equation. Okay, so now this one is similar to that one up there. It's a cubic. So figure out that h value from the locator point right there, then plus your k value, which will be that same value from that point right there. Okay. Okay, so now here, again, we're going to basically take the same approach for the rest of these. So figure out the vertex, whatever that is. So in this case, it's what, -3 and -6, and then use that to construct your equation. So plug in that x value, flip it around, and then check it on Desmos. Same thing here, but notice again, this one's pointing down. So think about what you got to put here, right? That means I got to put a negative. So same thing. Okay, figure out that vertex. Here, figure out the locator point and plug it in. But again, remember, this is cubed because this is one of those cube functions. Okay, so that's how you figure out on that page. Let's flip it over. Okay, so now on this back page, okay, we can use it. It's pretty much like the same questions. Okay, so now we're going to use the HK point or vertex or locator point to figure out the equation. And then we've got to state the domain. Okay, so go back to last week or week 1 to figure out the domain here. Remember, we got arrows to the left, arrows to the right. So think just hint, infinity. Okay, so I'll give you a little hint here that you're going to have parentheses and infinity one way, infinity the other. But remember, you have to remember which one's negative and which one's positive. Okay, the range is it going from the bottom to the top. So it starts at y value of 3 and then goes up to what? Notice they're arrows, right? So you figure that out. The equation again, just like we did in the last problems we just did, go ahead and plug in your vertex. Okay, again, here's a cubic function. So we're going to take that same approach. Okay, and here's another quadratic function. There's your vertex. So again, do it just like you did on the ones before. Okay, so now here, x plus 2 and then minus 3 is what we're going to use. And then for this one, we're going to use negative absolute value of x minus 1 and then plus 2. Okay, so remember that absolute value equations always are v's. They look like a v. And obviously if it's negative, then it would be a v that's pointing down. Okay, so first, again, we want to find that locator point, the HK point, and we do this same thing like we did on the other problems. Okay, so if that's positive, then it's going to be negative 2, and then that will be negative 3. So then we can use that to figure out what values to put in our table. So I'll put negative 1 and 0 because those are points to the right, or x values to the right, and then negative 3 and negative 4 because those are points to the left. And then I can just plug those in to figure out the rest. So first I'm going to graph the negative 2, negative 3. Let's start there. If I plug in 0, let's just start with that. 0 plus 2 is 2. The absolute value of 2 is 2. And then minus 3 is negative 1. Okay, negative 1, if I plug that in, negative 1 plus 2. Well, negative 1 plus 2 is 1. Absolute value of 1 is 1. And then 1 minus 3 is negative 2. Okay, now there's similar properties in that these graphs are symmetrical. So on the other side, I'm going to get the same values as I plug all these values in. Okay, so you can plug them in one at a time, but you're going to get the same thing going on the other side of the locator point. So we get negative 1 and negative 2 here, 0 minus 1. Notice how we're getting a straight line. And then to the left, we're going to get 3 and minus 2 and 4 and negative 1. So it's again another straight line. And I'm noticing it's kind of going up 1 over 1 here. So that means that it would go through that point there. And we're going to need to know that. Same thing over here on this side. Kind of goes up 1 over 1. So I need to know where it crosses because the next question is what's the x-intercept? Okay, well, I could continue the table to figure that out by going up to negative 5 and figuring out, okay, it crosses at negative 5, 0. And to the right, it crosses at 1, 0. Y-intercept, we found that here at 0, negative 1. Locator point is just that point in the middle. So negative 2, negative 3. The domain, well, going to the left, it goes forever. And going to the right, it goes forever. So in this case, we're going to use inequality notation in this case. So we'll just say all real numbers. So if it goes forever both ways, we can just say all real numbers. Okay, but range, it doesn't go forever up and down. Okay, for range, at the bottom, it starts at negative 3 and then goes up forever. So we'll say y is greater than or equal to negative 3 because it just goes up forever. Okay, so now in this one, same approach. There's our locator point. That's negative 1, so this is positive 1. That's 2, so we plug in that. So again, I'm going to plot that on the graph. So 1 and 2. There's our locator point, and we know this one's going to point down, right? But we want 2 points to the right, 2 and 3, and 2 points to the left, 0, minus 1. So if I plug in 2 here, Let me just kind of work this out so you guys can kind of know how to do the others. So 2 minus 1, and then plus 2. So 2 minus 1 is 1. All right. Then the absolute value of 1 is 1. But then we multiply that negative that's outside of it. So even though the absolute value of 1 is positive 1, there's a negative outside, so it becomes negative. And then we add 2, so the answer is 1. Okay, if I plug in 3, 3 minus 1 is 2. Absolute value of 2 is 2. Multiply the negative, you get negative 2 plus 2 is 0. Remember I told you these are reflective, or symmetrical, so that means that that will be 1 and that will be 0. They'll flip on the other side. Okay, so now we have 2, 1, 3, 0, and then 0, 1, and negative 1, 0. So there's our graph going the other way. Okay, so then our x-intercept right there at negative 1. And we can see that in the table, actually, right there where y is 0, and at 3, 0. We can also see it on the graph. Okay, so the y-intercept, well, it's wherever x is 0. So 0, 1, or right there where it crosses. 0, 1. And then the locator point, which is that point in the middle, which is 1, 2. And in this case, let's use set notation this time. So it goes forever to the left, so negative infinity. Forever to the right, which is positive infinity. And then you always put parentheses around that. Okay, so now range, what is it doing as it goes down? It goes forever. So negative infinity. Remember, going down is negative, right? And then it goes, the highest point of it is at 2. So comma 2. We can't reach infinity, but we can touch 2, so we put a bracket. Okay. Okay, then the last one, we're going to use the function, instead of square root of x minus 3 minus 5, we're going to use f of x equals x plus 2 and minus 3. Okay, so this function, you can also find the locator point just by looking at it. So if that's x plus 2, that means that the kind of starting point or locator point for this one is going to be negative 2, and then negative 3. So that's where it starts at. So negative 2 and minus 3. And what I'm going to do in this case is I'm just going to pull out Desmos. Let's go over to Desmos. And we're going to need the tools here, which I can't get to because the thing's in the way. Let's do this. That way we can kind of move things around. Oh, no, it's not letting me do it. Oh, I figured out how to hide it. Oh, there we go. Okay, so I need the square root. And then x, what did I say? Plus 2. And then minus 3. And make sure that minus 3 goes on the outside of your square root. So notice how it starts here at that negative 2, negative 3, and then goes off to the right. What I'm going to do is I'm going to get these points, maybe this one, and plot that on my graph. So this first one's at 0 and kind of like negative 1.5. So I'll first put that on my graph, about right here. And then the 7, let's focus this a little bit. Okay, and then that's 7 point, that's 7, 0 was here. So it kind of like curves and goes off to the right like that. Okay, so graph and completely describe the function. So when we say completely describe, we're talking about these things here. So first let's talk about domain. Okay, so domain, it starts at negative 2. And I'm going to use inequality notation. It starts at negative 2 and goes off forever. So that actually means that since it goes off forever, that x is greater than or equal to negative 2. So there's no negative there. Okay. And then the range, it starts at negative 3 and goes up forever. Kind of goes, it doesn't go like straight up, but it goes slowly up. So slowly it's going up forever. So y is greater than minus 3 in this case. Okay, so now let's talk about the x-intercept. Well, we've just figured that out. It was at 7, 0. Okay, by just looking at the Desmos graph right here. That's where it crossed. And then the y-intercept was this point right here, which was about like 0, negative 1.6 So we'll say 1.6. Okay. So y-intercept 0, negative 1.6. Okay, so then what else do we want to know? Maybe the locator point. So the locator point, which is also kind of like the name for the vertex, like in a parabola. But since it's not a parabola, we call it the locator point. That's -2, -3. Okay. What else do we want to know? Okay, so yeah, that's pretty much all we really need to know when we're describing a graph. Okay.